Okay. Well, hi everybody. I'm David Klee. I'm kind of a nerd of all trades. So I was joking about the webcam. A lot of times, webcams are really hard to come up with because you don't know where you're going to be. You don't know what kind of bandwidth you've got. So I put this together to simulate me talking.
Pretty good.
So I'll turn the webcam on now. So I figure when in doubt, it's good to laugh at a little bit of everything, right?
That is right. So just so you know, David, you're at the very top of our projector screen,
Cool.
and you're half cut off on the edge of the screen. So and it's very small, unfortunately. Must be. You know what? Let me see if I can. Oh, look at there we go. Hi, David. Now we can see you.
Hi.
Now you're nice and big.
Got everything?
Yep.
Cool. Okay, what I'm going to do is I'm going to switch this to full screen. Okay, can you all see that okay now?
Yes, we can.
Excellent. Cool. Well, I am David Klee. I started my own company 3.5 months ago, and right around the same time I was lucky enough to have a really good conversation with some of the folks from the Linchpin people. So they are kind of a conglomerate of some of the best in the business, and I was ecstatic when they asked me to come on with them. So it's a lot of fun. I have just a blast working with them. I still do some things on the side, but we have a lot of fun together. What you're seeing here is it's basically the core of the presentation that I gave at the SQL Summit this year. It's called Squeezing Top Performance from Your Virtualized SQL Server. A little bit about Linchpin people, not to do any marketing or anything, so I hate that kind of stuff. If you have any kind of performance or wellness or virtualization questions, you can call us. We're happy to help. We have a lot of fun with this. I cannot speak highly enough about the other guys in Linchpin. They're just incredible. I mean, Brian Moran, Andy Leonard, Mike Walsh, Tim Radney, just
voice goes out.
You're popping in and out now, David.
What happened?
No audio.
Lost his voice.
You lost your voice.
Kind of popping in and out.
Let me see.
Video still too.
Hello?
folks.
You know what? That might be the internet connection. Uh-oh. No. Hey, David, you there? So, all right. Attempting your audio will not be recorded during this time.
Can you hear me?
Hey, there we go. I don't know what happened there. I think
That's weird.
Yeah, GoToMeeting must have dropped the audio because we could see your slides, but we could not hear you at all. So
Huh.
that's
How long was it out?
5 minutes.
Yeah, about 2 minutes.
What?
Maybe 2 minutes. There.
Oh wow.
Yeah.
Could hear it dialed in, so
Oh,
works fine remotely.
okay.
Huh.
So it's on our end then. So hopefully it won't
Okay.
happen
If it
again.
does it again, send me a quick message. It did pop up over here, so.
Okay.
Okay.
I was not. I haven't taken a bite yet.
Okay. So what we've got is this is supposed to be an interactive discussion. I want this to be a lot of fun. I don't want to just sit here and blab the whole time. So I've got kind of a fixed agenda here, but any questions you have, anything you want me to expand upon, anything, just feel free to interrupt, yell. If you're in the same room, you could throw something at me. anything, just let me know. I want this to be interactive. That's where I have the most fun. So from a scale of really, thumbs up to thumbs down, where would you all rate yourself in how much experience, direct experience you have with virtualization? Anybody?
So a lot of zeros.
Okay, so believe it or not, the 1 to 2 to 3 range out of a 10 is where I kind of anticipate folks are going to be. There's a heck of a lot of really good DBAs out there, but when it comes to hands-on with virtualization, I tend to start from the ground up, and that way we're all on the same page. So it starts off kind of slow, but these are fundamentals that we build upon, and eventually we end up with a demonstration here of everything that I talk about in this whole presentation. We're building a SQL Server template, tweaking, tuning, adjusting a few things, and at the end of the day, I have the results from a test that I ran in my home lab where I demonstrate a tuned SQL Server VM versus a non-tuned, and a DVD store-based workload on there, and I show you the performance improvement of tuning it. It's the exact same hardware. It's pretty cool. Okay. So virtualization, what is it, and as DBAs, why do we care? Okay, well, first of all, what really is virtualization? It is fundamentally an added layer on top of the hardware. Everything that you see from the operating system and up essentially resides on the physical hardware, but it's abstracted away from that physical hardware. From a hardware standpoint, I treat the hardware more as resource queues than I do a finite amount of CPU, memory, and storage. It's pretty cool. A lot of people, what they do when it comes to virtualizing things...
That's not business hours.
Go ahead.
Sorry.
Oh, that's okay. A lot of folks, when it comes to virtualization, they think P2Ving a server and that's about it. Well, I'll tell you, in a solo SQL Server environment, it's not optimal. The second you start expanding that out to tens or hundreds or even thousands of SQL servers in an environment, it just gets even worse. So it's not, there's this whole process and methodology around there where a lot of things that DBAs are really used to can change, and they can change for the better. Now, again, like I mentioned before, most DBA's virtualization experience is fundamentally some management group comes to you and says, hey, you're going to get virtualized next week, and then that's about it. How many of you have actually had this happen?
Anyone? Couple hands. Apparently
Couple
it was
voices.
last week.
So for those that didn't raise your hand, how extensive do you have your SQL servers virtualized today? Is it 100%, 50%, none? Where are we at?
98%.
So you got to. It's all over the board, but it tends to either be 0 or all.
Okay, well that's, the 0 means there's a lot of room for improvement, but you've got an open playing field there in front of you where we can do this right from the ground up. For those of you that are close to 100% virtualized or 100%, there's going to be a lot of tips in here that I want you to take back to your virtualization administrators and talk through a lot of this with them and see how they've set up your environment today. And maybe there's some things in here that you can do to really tweak and tune the environment so you can get a lot better performance out of it. Now, from a technical standpoint, Hyper-V 2012 R2, vSphere 5.5, even Hyper-V 2012 and vSphere 5.0, 5.1, these things are so complicated and so advanced and so mature as products that I honestly do consider the virtualization layer functionally transparent when it comes to performance. I didn't used to be able to say that. But when it comes to the virtualization overhead of having to schedule these resources, if the hardware is identical and it's one VM on that physical machine, you will get functionally equivalent performance. Now, it's when people start designing this stuff for consolidation that you start to get into some trouble, and I'll talk through that. Okay, as of right now, vSphere 5.5, Hyper-V 2012 R2. There's some other players in the industry here. I don't necessarily see a lot of SQL Server virtualization on these, so for the time being, I'm going to let those go. Now, as those products mature and the management gets a little bit easier and I start to see more adoption, I'm definitely going to add those in and get more hands-on with those and start to add some tips and tricks for those platforms as well. But for right now, I'll leave it alone. Now, this is one of those things that's not necessarily about performance, but I always get a question on it. Fundamentally, when you look at the cost of virtualization versus the cost of SQL Server licensing, I could care less what the hypervisor costs, because no matter what, it is strictly a rounding error when it comes to the overall cost of this environment. So don't let some of the marketing hype fool you. Oh, it's free, you know, the other one is so expensive. I see a lot of that. I want you to pick the platform that is best for you, it's best for your environment, it's whatever you know how to manage the best, because functionally at the end of the day, they do the same thing. It's what you're most comfortable with now. Okay, so from just a basic level, how much hands-on experience do you all have with the hardware underneath your SQL servers?
About half.
Okay. So what I'm going to do, just from just the physical hardware, Sean. You know, is it you know, do you have a good amount of hands-on with it, or is it, or, you know, a lot of shops are basically where you've got 10 years, outstanding. That's great. Okay, so for those that don't have a lot of hands-on with the hardware underneath, generally in an environment today, whereas it's a bunch of physical SQL servers, what you've got standalone equipment. You may have some local disks for the operating system, maybe the SQL Server instance installation base, the home, but then you probably have a SAN there with some lines carved out, and you'll put data and logs on there, and you know, however you have it set up, that's kind of generally the model. So a lot of times you'll have local disks, and this has worked great for a lot of years. When you hit the virtualization, or, you know, I hate the cloud buzzword, but, you know, technically this is private cloud architecture. So I just call it virtualization because when you hit the public cloud, then it's public cloud because you don't have control over the infrastructure. But anyway, what you've got, you essentially have the same or close to the same physical hardware underneath. You still got, I mean, it's memory, CPU, network, interconnects. You still got that SAN. You've still got some LUNs carved off by your storage folks. But instead of directly connecting them to just one physical machine at a time, you configure it in a way where they are connected to all of the machines. And that way, a virtual machine is not tied just to one physical piece of equipment. And then what you do is on each physical machine, you add the virtualization layer, which is a tiny, tiny, tiny operating system. And then from that point forward, you can start deploying VMs on here and do whatever you need. You're not necessarily tied to any one piece of hardware underneath. Now, that was the physical model of a, physical, virtual, whatever. A lot of buzzwords. From a logical standpoint, you as DBAs, you don't necessarily have to worry about the hardware underneath. You know, what you were is layer, and I have resources at my disposal for my SQL Server. So, you know, in this example, I have 150 gigahertz of CPU, 4 terabytes of RAM, a whole truckload of network adapters, and then different tiers of storage with performance characteristics. And then at this point, you can start carving up and distributing these resources into your own virtual machine layers. So, you know, the VMs can be configured however you want. You can just start slicing and dicing there. Any questions up to now?
Those of you online, if you just type in a chat window your questions, that would be helpful.
Cool. Okay. So historically, people have been virtualizing stuff for quite a while. In the grand scheme of IT today, quite a while. You know, a lot of companies have been virtualizing since 2003, 2004, sometimes newer, sometimes older, just depends on where they're at. The biggest draw for virtualization is raw instance level consolidation. You can take a football field of a data center down to a row of racks. I mean, you can take 50 physical servers down to just one rack full of equipment. It's really amazing what it can do. But the problem is, over the years, people have kept this concept of extreme consolidation. But when it comes to these massively resource-intensive applications like SQL Server, Oracle, SAP, Exchange, a lot of the Java application servers, a lot of these things are very, very resource-intensive. And when you put these things in an environment that is designed for consolidation, they're not designing that environment for the performance of your critical system. They're designing it so that they can get the maximum consolidation ratio on there. When it comes to virtualizing these big critical systems, I don't like to focus on consolidation ratios. You know it's going to be better than 1-to-1. But I design for performance because that's what the business demands. That's what you need. The biggest thing here is if you put a SQL Server in an environment that was designed for consolidation, I guarantee you're going to have performance problems, and people are going to be really upset. It's not a lot of fun. And you're exactly right. Mainframes really have been doing this since the 60s. Virtualization is basically mainframes with commodity equipment. They're a little easier to manage. There's a whole new set of buzzwords, but the concepts are close to the same. It's a lot of fun. Now, all of these little negatives here, they don't have to be like that if you design from the ground up with performance in mind. So what I like to do is I will go top to bottom in the environment, and I'll go through and take a really good look at this stuff and say, how can we squeeze the most performance out of this? It really does make a difference if you look at every piece of the puzzle. So at the host level, in a virtualization environment, this is the physical equipment, the physical compute node. A lot of times you talk to a virtualization admin, you say, I need a new server, and they go, great, let's get the most number of cores that we can get, because it's the same licensing cost for them. Well, I can go buy a 12-core machine today and each core runs at 2 gigahertz. Or I can go buy a 10-core and each one runs at 2.8 gigahertz, 2.6, 2.8, something like that. So if you do the math there, for 10% less cores, each individual thread that is executed on that entire platform could be 40, 30% faster. So take your baselines of your environment, figure out where you're at, and if it makes sense to squeeze in more cores so you can get greater consolidation, do it. But a lot of times I may actually talk to people and say, hey, let's go for a little bit lower core count at greater individual speed, because if you're licensing the entire cluster for SQL Server, it may actually make sense to buy more compute nodes with less cores if each individual core runs faster. The other thing here is make sure that the physical machines are just maxed out on RAM. Be reasonable with it. But when get more than you need, for now, because it always goes up. But the bottom line here is don't just drop the memory in the physical machine. Every single manufacturer out there has memory performance guidelines as part of their configuration. So the link here will actually take you to a sample HP DL series memory configuration guide. Little things like normal Nehalem-based CPUs. It's got banks of memory per CPU. If you put some of these in the wrong order in there, it can actually decrease the speed of the memory by up to 3 times. So it'll go from triple channel memory down to single channel. So a lot of times it may make sense from a performance standpoint to get greater density chips, less of them, and just populate certain slots in there. Every hardware manufacturer out there has a guide for this. So work with your hardware guys to see how they've configured the memory and make sure it's optimal. It might just be as simple as turning the machine off, moving a couple sticks around, and turning it on. There's other weird things here. Inside the BIOS, make sure you have the operating system controlled CPU power management set to on. A lot of times out of the box, these things will come with balanced performance set, and it can actually really hurt the performance. It may actually artificially throttle each one of those cores down by up to 25%, and you won't see that in an event log. Another thing here, and this one is more common nowadays, CPU virtualization extensions are added into the BIOS. You can turn that on. Basically, it allows the BIOS and through VMware and Hyper-V to actually present the architecture of the motherboard to the virtual machine. So anybody here familiar with NUMA?
Did you say NUMA?
Yeah.
Yeah. Yes. A lot of people here are familiar.
Awesome. So what you can do with vSphere 5.0 and Hyper-V 2012 and above, you can actually now configure that virtual machine. So you can pick the number of virtual sockets with the number of virtual cores, and you can actually extend that NUMA info into the VM to get better performance, because SQL Server is NUMA aware. Dumb things there. I'll go into some of this in a little bit. But you can actually tune the VM the way you want it. But if you, in VMware, if you have less than 9 virtual CPUs, NUMA doesn't get extended, even if you pick that. There's an override flag, and I actually put this on my blog about a month or two ago. You can actually extend NUMA at whatever CPU count you want. With the hosts themselves, one of the biggest things, and Hyper-V won't let you do this, but VMware will. So let's say I have 3 web servers. I give them 10 gigs of RAM each. What if they're only using 4 gigs of RAM? So fundamentally, I'm only using 12, but I've allocated 30. If you take a look at that, realistically, I'm only using that 12. So I can put more of those web servers on that physical machine and not max it out. I may be using, let's say, 100 gigs of RAM, but I may have allocated 200 gigs. What if I only have 128 gigs in the physical machine? And then I run antivirus scans on everything at once by accident. Well, they're going to try to consume all kinds of memory to fulfill that task. You may actually now exceed the amount of memory needed than what is actually available in that physical machine. And if you don't have enough of these resources in the cluster, the hypervisor level can actually start to try to reclaim memory. VMware calls it ballooning. But it's basically the host is going, I need more memory to operate right now, so give me memory. And it will force certain virtual machines to start paging so that it can grab some of this memory back. SQL Server doesn't like to page. I do not like to see any paging or ballooning in a hypervisor environment. So I always say do not overcommit any memory if you're doing anything business critical SQL Server. Just guaranteed. If you just plan for it, you're not going to get into any trouble. And then at a physical host level, and again, this one kind of varies, but I try to plan for no more than about 80% resource consumption per physical machine, because that way, if I've got a big enough virtualized cluster, and I power supply or motherboard fries or something, you've got extra capacity there to be able to handle having these VMs fail over. Are there any questions up to now?
David, I have one.
One question. Sorry.
Yeah, when you're dividing it up, and let's say you've got 5 SQL servers per host or whatever. One of the arguments, discussions I've had with our guys, virtualization guys, they always want to start with one CPU. And there is actually some documentation that's saying it's better to start with 1 versus 2. I always like, if I have a database server, no matter what it is, I always like 2 because of backup channeling and so on and so forth. Have you heard either way whether you should have start with 1 and then expand, or what's your view on that?
Okay, I think I heard the majority of that question. Was it basically, from a starting point, is it better to start with 1 or 2 vCPUs? Is that correct?
Correct.
Okay, from my standpoint, I always start with 2. The biggest reason there is if you start with 2, Windows Server by default will load the SMP kernel extensions, and therefore if I need to add more at a later date, you can do it and you don't incur a second reboot in order to make that work. A lot of folks will start with one. I always start with two. SQL Server was built from the ground up to be SMP aware. I generally don't see a need to go less than two. Did that answer your question okay?
Yes.
Awesome.
Oh, one more question.
Yeah.
We talk about host and multiple VMs, right? So my question is there like a single point of failure? If the host fails, all the VMs are gone, how do we manage that?
So, David, I don't know if you can hear
Yeah.
that or not. So the question.
I could not.
Okay, so the question was about, you were talking about hosts and whether or not there could be a single point of failure in that environment.
Yeah, absolutely. I can definitely address this one. And you guys are going to chuckle, but within the next couple of months, a friend of mine and I are going to be starting a SQL virtual chapter on high availability and disaster recovery. So this is a fun one. Without any of the SQL Server-based high availability features, in a physical world, let's say a motherboard fries, that machine is down until that physical machine gets repaired. From a virtualization standpoint, and it's actually on this slide right here, from a virtualization standpoint, you can enable cluster load or cluster-wide load balancing. Now it does a double feature here I don't put on the slide, but what it does is if I have a physical machine fail, what it will do is whatever management thing you've got, so VMware's vCenter, Hyper-V is SCVVM, what you've got is the ability to detect the physical machine failure. It knows what VMs were on that physical machine, and it will remap those virtual machines to other hosts that are still up, and then it will automatically refire up those virtual machines. So what I like to say is, in a very simple environment, you actually can get away with roughly I like to say a 4-minute SLA for the mean time to recovery in the event that a compute node fails. Now, when it comes to single points of failure, what that will do right there is that gets your machines back up if there's a physical failure. It doesn't cover you for patching, things like that. Now, in the rest of the stack, the networking you want to make redundant, so if you drop a switch or a port, all you do is get an email and life goes on. There is one single point of failure in a lot of these environments, and that is the SAN. The SAN is not immune from failure. In fact, one of the other folks from Lynchpin spent most of the week this week on site somewhere. They had a SAN whose vendor shall remain nameless, but it wasn't their fault. But on a 15-disk SATA array, they had 4 disks fail at once. Not good. They had about 60 virtual machines on there, and we'll just say their recovery procedures got a really good test. So if you have such an absolute requirement for high availability, what you can do is you can actually use virtualization in conjunction with SQL Server highly available features such as availability groups or database mirroring, and do something with the SAN, such as either SAN to SAN replication or a clustered SAN with virtualized storage on top of it, and you actually can dramatically reduce the downtime from these points of failure. So, did that address your question?
Absolutely, almost addressed. What is the virtualization?
What about the green bar, the virtualization area? Is there a single point of failure there?
What you've got, the virtualization piece, you have multiple components in there. You actually have a hypervisor that is installed on each physical machine, and then you have a centralized management piece on top of it. The centralized management piece technically is a single point of failure, but it does not stop the operations of the entire cluster. All it does is simply reduce the amount of time, or excuse me, it increases the amount of time needed for some of the automatic watchdog features, such as cluster balancing, automatic failover, things like that. You can make those highly available. Both vCenter and Hyper-V, the Hyper-V components can be made highly available so that you don't have single points of failure.
All right, you got the thumbs up.
Awesome. Cool. So I actually talked through this slide in the answer to that question. In addition to removing a lot of the single points of failure, this particular thing, you can actually enable automatic cluster load balancing. So let's say I've got a SQL Server that's doing a backup in the middle of the night. CPU is running high because I've got compression, encryption, whatever you want turned on. The virtualization management layer can actually detect when a physical machine goes out of balance with the other ones and can automatically load balance virtual machines between these physical machines, and it can do it in a way that is not disruptive to you as a user at all. In fact, you won't even notice. It's incredible. VMware calls it vMotion, Hyper-V calls it live migration, and it basically will just move a virtual machine from one physical machine to another. It copies the contents of memory, flips a switch in the network routing, and life goes on. I mean, it will drop one ping when the ARP request gets redirected to the wrong switch port. That's it. Any TCP application will simply detect that and will do a TCP retry, and life goes on. It's really, really cool. Are there any questions there? Because that's one of those fun topics that can get a little bit deep.
All right, one question coming.
So on the vMotion, so you're actually not moving over the disk, you're actually just moving over the memory, is that correct?
On the vMotion, here, let me see if I can repeat that. So on the vMotion, you're not actually moving the disks, you're just moving.
That is correct.
Okay.
That is correct. What I'll do is I'll go back here to this particular slide, and what you've got is the virtual disks will actually sit on one of these LUNs. So on a Hyper-V system, it could be a SAN LUN, it could be SMB3, and the access is shared between all of the physical machines in that virtualization cluster. What happens then, if one physical machine goes down, they can all see where those files live. What happens when you do a vMotion or a live migration is server A starts to copy the contents of memory to the target server. And when it's done with one pass, it looks at what's changed, copies what changed, looks again, and it repeats that process until the delta is 0. At that point, it actually flips something in the switches itself that will redirect all the inbound requests to a different network adapter on a different machine. It's so fast that you will physically drop one ping. It's just that TCP reach. Virtual disks all stay the same. Execution of that virtual machine has a result. You can move out.
Hey, David,
not
just
move this stuff. Well, great with it.
Oh, you're back. You slipped out again. Hopefully you're back.
Cool. Did that answer the question?
That was a little gibberish.
Yes.
Say yes.
Could you repeat that?
No, now you're coming in loud and clear.
Yes, pretty much.
Yeah. David, just so you know, there's a chat question. Given that the backup example.
Can you now?
Oh.
Okay. Cool. I have a question in the chat window here. Given that the backup example would have the SQL box very busy, would it move other VMs off the physical machine? The answer there is it all depends on how busy those machines are. If it determines that it's easier to move the one hot machine than, let's say, 30 small machines, it may actually move that. Otherwise, it may actually determine that it's easier to move the smaller machines, and we'll go ahead and do that one. So the fun part of there is you can actually set how aggressive it is to do that migration. So you can say, really aggressive, or you can say don't do it unless you absolutely have to. It's pretty cool. Sean, did that answer your question? Excellent. Okay. So I just talked about storage there. There's a number of things that I would really stress that you talk through with your virtualization admin. You all know that SQL Server and these really heavy database engines are some of the biggest consumers of storage that you will ever find. A lot of times when you virtualize this stuff and you park it in their environment, they may not have configured the SAN for performance. They may have configured it for just simply size. So what you can do, and I'm going to jump to the second column here, what I want you to do is to actually get some of these tools, benchmark the storage that you have today. One of the biggest things I love to use is SQL I/O. It's free from Microsoft. You've also got IOmeter, you've got Crystal Disk Mark. They work beautifully, but what this will do is it'll tell you things like maximum throughput at the type of test that you have. You've got the latency involved with it, and you've got the IOPS. Now, SQL Server, all of those matter, especially latency. SQL I/O is one of the best ones because it gives you a latency histogram there, which I just absolutely love. And if you email me, I will send you a link to somebody else's blog where they actually have a PowerShell script that will go through and will generate a number of sequential tests that will test a lot of different permutations of storage patterns in your environment. And it'll extract all the info so you can take a really good look at the numbers. With those numbers, especially the latency numbers, you can take that to your storage admin and say, hey, my workload demands more than what you're currently able to give me in terms of raw performance. What can we do to improve this? So when it comes to type of storage, there's local storage, but I don't like that because now you have a single point of failure in that physical machine. Now that said, if you need raw maximum IOPS, it's a lot cheaper to go this way. And if you do things like multiple physical machines with availability groups, you might be able to get away with that. Again, yeah, it's kind of iffy, but I don't see a lot of that, but it is an option. Now there's traditional fiber channel on these big massive SANs, or a lot of the newcomers are going IP-based. So SMB3, iSCSI, NFS, all these things work really well. It all depends on, can you get storage that's faster than what you need? Simple as that. One of the biggest things that I always see is multipathing. So I've got a funny example here. I never want to speak bad about any other consulting group, anything, but about a year ago, when I was working at my previous job, we got a call from one of our partner organizations, and they called us in for SQL Server for SAP on VMware, performance problems. So you all know where this is going. They called SAP. SAP took a look at their environment. They have this one screen that every time, there were like 12 people, they would refresh the screen and new orders would come up and they'd go fulfill the orders. Every time they had to refresh the screen, it was a 10-minute query. And about half the time, it would time out after 10 minutes and they'd have to sit there and click it again. It was really, really terrible. Well, SAP told them they needed faster storage. So $1.2 million later, it didn't fix it. It's scary. 8 months later, 4 other consultant groups later, $250,000 in services later, they didn't fix it. It was the same as what it was. And these people were getting really upset. Well, our partner organization found out about it and brought me in. And by this time, the CIO is just so furious. He said, "You've got 2 days, and you owe me a steak when you can't figure it out because you were just wasting my time." It's like, okay, I'll take that challenge. Well, 45 minutes into day 1, I discovered the underlying cause of the problem. When they hit the button to refresh that screen, so now this is an EMC VNX array, it had truckloads of SSD, it had a whole bunch of 8 gig fiber ports on the controllers, active controllers, just you name it, it was like the fastest thing you could buy. It had a Cisco UCS environment, 8 gig HBAs, I mean, just decked out. Well, they'd hit the button to refresh the screen, I'd watch in the VMware environment, the performance spiked 380 megs a second, and it just stayed there flatline. 10 minutes later, query timed out, storage returned 0. It's like, what is going on? Really weird. So I got poking around in the environment, and 2 things popped up. One, they had 8 gig on the host, 8 gig on the storage. They had a 4 gig SFP in the fiber switch. So a $200 part just crippled a $1.2 million array. And then I got to looking at it even more, and even though they had 8 gig fiber adapters, they were only using 1 at a time. So we downloaded the trial of some multipathing software from EMC, installed it, they hit the button again. It went from 400 megs a second to 6.1 gigabytes per second. Blazing fast. It was incredible. And as a result, the query now took about 20 to 30 seconds. And roughly about 3 minutes after we made that change, somebody comes running into the NOC going, "What did you do? What did you do? It's awesome." It's incredible. No multipathing software, and just this holistic approach to the environment. Nobody looked at the whole thing. It was amazing. Now, that said, the real cause of this was that stupid SAP software. Whoever had written this module, as an add-on, they had pulled down 160 gigs worth of data to refresh a screen that had 5 rows on it. Yeah. Now that said, I pointed that out. I showed them how to rewrite the query. We added a couple index recommendations. They were going to send it off to their SAP consultant to test. But in the meantime, the business was now able to function. My gut tells me that after all of that, if they actually did the changes that I recommended, they'd probably get that query down to less than a second. Yeah, at that point, the execution plan was it was insane.
So
but at the same time,
so David,
it was just yeah.
Yeah, we all want to know how you enjoyed your steak.
That was one of the best steaks I've eaten in quite a while. And the funny thing is, we're in the NOC. I see the second of the problems, and I call it out to the CIO. And he's sitting at the table across from me, and he's got, I swear, it's like an 80-ounce cup of coffee. The guy was nuts. And he sees it, and you could see the gears turning in his head, and then it clicks. And he smiles, and he goes, "Great job," and then he throws as hard as he can, and he gets like, why in the world $1 million
Sorry, David.
This is the difference. It's every layer of the hardware. DBA.
Sorry, David. You were getting a little choppy there in the middle of that. So
One of these tiers. All of this stuff. Impact really does make a difference. Things still good.
hello.
Are you okay?
Yeah, fine online.
Weird.
Yeah.
Alrighty. So you can hear me fine. David, can you hear me?
I can.
Okay. So I was just telling the group here, the group was gifted with a GoToMeeting subscription, and this is our first time using it, and we're having a lot of audio issues. Now, I don't know if it's with our wireless connection here or something in the presentation software in and of itself, but in any event, just keep plugging away at it, and hopefully we will stay attuned.
I think it's on the wireless end on your end, because the other folks that are in through the webinar software can hear just fine through the whole thing.
Okay. Well, hopefully, since this is recording, it's recording up on the Citrix side on the web somewhere, and not on my environment. So continue.
Yeah, you bet. Okay, so up to now, I mean, one of the big questions that I get is, okay, well, do I set up my array for RAID 5, RAID 6, RAID 10? You know, how many disks in a disk group? All these things. My answer is always, I don't care. I know it sounds weird, but what I like to say is, you need to set up the array so that it will handle the workload that you need with room to spare. I have seen arrays configured for RAID 5, stomp on arrays configured for RAID 10 because they have more cache. You know, I've seen slower arrays with faster interconnects and better multipathing do really well. So the biggest thing is just buy what SAN has the performance that you need, and just make sure it's set up right, and then constantly monitor the performance to make sure you're not over allocating that SAN. That's the biggest thing. Now, there's one thing with VMware. By default, VMware on Windows will use the LSI Logic Virtual SCSI Controller. That's there for compatibility's sake, but it's not necessarily the most performance optimized. What you can do, VMware comes with an extra driver that they wrote called the VMware Paravirtual Hard Drive Controller. You can actually retrofit an existing virtual machine to take advantage of the PVSCSI driver. What it does is it will get you roughly 12% better performance, a little bit lower latency to disk, and a little bit lower CPU associated with I/O activity, and it's free. 2 reboots and you're done. No big deal. It is beautiful. It's free. Use it. I'm actually going to have a blog post up in the next couple of weeks talking about how to go retrofit an existing VM with that. But if you're raring to go with that anytime sooner, just let me know. I'll send you the write-up. Anybody out there using tiered storage for anything?
David, real quick, there was a question for you in the chat window.
You bet.
Yeah, is that Windows host or guest?
That is actually within the virtual machine guest itself. So what you will do is at the virtual machine configuration layer, you can change the type of controller that you're presenting from LSI to Paravirtual. You have to do that with the VM off. You turn it back on, it'll detect the driver, you reboot one more time, and everything should be there. So again, if you send me a quick email, I'll actually walk you through exactly how to do that. So it's easy to do, 2 reboots, you can do it in any maintenance window, and it just works. Cool. Okay, so if anybody out there is using tiered storage, I like tiered storage as long as the latency when it has to jump between tiers doesn't kill you. Compellent, 3PAR, VMAX, VNX, they all work really, really well. I like, you just have to make sure that it's performant. Simple as that. Okay. Who all here has got some concerns with their networking? Oh, I'm sorry. Okay, what is tiered storage? Tiered storage is basically, I have an array that has multiple kinds of disks in there. So your average compellent system, for example, will have a bank or multiple trays of SAS disks, and it'll have that in there for speed, and then it'll have a tray of SSD, so that and it's not necessarily, you might have, let's say, a terabyte of SSD, 5 terabyte or 10 terabyte of SAS disks, and then it'll have another couple of trays of serial ATA or SATA drives for capacity's sake. a lot of times the one line with mixed underlying disks there, it is exactly presented like that. And what it'll do is by default it'll drop everything to SSD. And then if that block on the SSD has not been accessed in some period of time, it will actually move that down to the next tier of disks that's slower. So it will go SSD to SAS and then to SATA. And what happens is you get the stuff on the fastest possible disk that's frequently written to or read from. But if it's just archival data or if it's just old stuff, it'll move it down to the larger capacity but a lot slower disks. And that way you get the best performance, you get the best bang for the buck. So sorry about that. I should have explained that.
David,
does that answer your question?
There's a follow-up question to that.
Cool.
Which was one LUN with mixed underlying disks?
Yeah, a lot of times it will present it as one LUN. Okay. Other times you can actually you can break them out and present them individually, but you get, as long as the array can handle the latency of jumping between tiers, it's probably easier to use the one LUN with the mixed underlying disks because of simplifying management. And that way you can really maximize the slower disk's capacity and not have to constantly tune stuff. Okay, so the networking stack here, so SAN replication, in fact, VM performance. That is a really good question. You know what, I'll tackle that right now. SAN replication itself should not impact performance at all. That said, that's in an ideal, perfect, happy world. It all depends on the SAN and how it's configured and how big the pipe is between the two SANs, and if they have it set to synchronous or asynchronous replication. If it's like a normal SAN replication, now, okay, Sean, are you doing this for high availability purposes or for disaster recovery purposes? If it's DR, there's a very, very high probability that is asynchronous, in which case, functionally, you should not see any performance impact. Now, is that the case in your environment? Uh-oh. I'll tell you what. When this completes, if you want to get on audio, let's talk through that. I'm very, very curious to see what your experience is like there. So please remind me when this wraps up, and we'll definitely talk through that. Okay. Cool. Yeah, we'll talk through that. They need the down to 4. If they had free utility at the bit.ly link there, you go, and again, it's free. I love to use one server. Set another for this from just a couple. What the theoretical max, up what you're doing and take and really take a good look at what's going on, because eBay, PayPal, they were about to have just doom and gloom. A networking switch was just about to poop out, and we found out by chance that it was not configured in a redundant manner. So they were about to have a bad day. we used this tool, we validated that everything looked good after we fixed it, and it just works. And again, it's free. It works really well. Whoops, gone again. Uh-oh. Cool. Well, I'm going to keep going. This should be on the recording. Let's see, Brett, let me know when you're back on.
We can hear you now.
Okay. Cool. So each of the major hypervisors out there have just ridiculous maximums for what you can do to these virtual machines now. vSphere, you go up to 128 virtual CPUs, 2 terabytes of RAM. Hyper-V 2012 R2, you can do 64 and 1 terabyte. Realistically, you can present multiple petabytes of storage to a single virtual machine. You know, if you can't virtualize it in these maximums, I want to see your environment because that's impressive. Now, just because you can build VMs this big doesn't mean you should. Please. Here's one of the biggest problems where people can get themselves into trouble. It's with the actual virtual machine configuration itself. One of the things to do, you can actually pick the type of operating system that the virtual machine is running. VMware and Hyper-V will actually subtly kind of tune things underneath to make sure that stuff just works. The virtual machine vNUMA configuration, so number of virtual sockets and number of virtual cores. You want to try to get this to mimic your physical machine as much as you can. So, you know, let's say I've got two physical processors with 8 cores each. I probably don't want to create a VM with 1 virtual socket and 8 virtual cores, because the hypervisor may not be able to always guarantee that all that's going to be on one, and therefore memory access and the CPU scheduling is going to be a little weird. I would do maybe 4 virtual sockets with 2 virtual cores each, or 2 and 4, however you want to do it. And you can reboot the machine to try these different configurations all the time. VRAM, it's a little less important than the other. Use what you need. With SQL Server, generally speaking, the less RAM, the more I/O you've got. You know, balance that one. You all are, I'm sure you're very good DBAs and you know how to size memory just fine there. Memory reservation is one of those things. So I talked before about if the hypervisor needs more memory, what can you do to ensure that no memory is ever stolen from that virtual machine? So there's a way at the virtual machine layer to check a box to give it a full memory reservation, meaning in the event that you run into problems with that virtual machine is guaranteed to always have all the memory guaranteed to it. Other VMs may suffer, but in this case, you'll never have to worry about it. Now, Hyper-V gives you something called dynamic memory. So if I've allocated a VM 10 gigs and I need 12, it will actually temporarily spin that VM up to 12. I don't necessarily like that because that tells me you may need to monitor that VM's memory allocation a little more closely, or potentially even drop the SQL Server instance max server memory to give the overhead, to give more overhead there for the OS. Now, a lot of these things, if you're using Enterprise or Data Center Edition of the OS, you can do CPU and memory hot add. As soon as you do that, you remove the NUMA presentation, so it may be more inefficient there. So it's something to weigh. If you need that extra layer, go ahead and add it. If you don't enable hot add, and within SQL Server you can actually see the NUMA nodes in there. So one question here is virtual disks versus those raw device map. I always use virtual disks whenever possible because you get the maximum amount of tooling from that virtual machine layer without any of the extra management headaches of having to do the raw device map or the pass-through disks. Now that said, there are a couple of situations where you really do need to do the pass-through disks, and the biggest one is with traditional Microsoft clustering with shared storage. With VMware, that's a requirement, unless you do SMB3 on the other end for the shared disks. It's one of those things you have to use that, and as a result, you lose the ability to migrate that virtual machine while it's turned on. You can fail over the cluster. power the VM off, move it, but there's that brief blip while the cluster fails over that you do have to worry about. Now, one of the biggest things here is what I call right-sizing that virtual machine. And this deals primarily with CPUs. The biggest thing here is if I have a physical machine with 16 cores in it and I virtualize it, do you need all 16 of those CPUs in the virtual machine? And the answer is, well, of course, it depends. But realistically, if the workload is not using all of those CPUs, it might actually be slowing you down. And it sounds counterintuitive, but the way I like to say is in the physical world, you want to size that physical machine for what you need at the end of that machine's life, so that way you have a lot to spare for pretty much the whole life of the machine. In the virtual world, you really need to size that VM for what you need right now, because you can always adjust this. Think about it this way. If I have, let's see, blah, blah, blah. There we go. The biggest thing here is what's called CPU scheduling. So fundamentally, virtualization is turning these physical resources, so storage, network, CPU, memory, into a resource queue. So the biggest thing here is with CPU. Now let's say I've got this layout, one physical machine that I'm worried about, and 8 virtual machines. Now if I have a handful of tasks, things that need to be executed on the physical machine, and I put them in this CPU ready to run queue, it's going to get executed really, really fast. Okay, but now if I have a whole lot of tasks, because I've got a lot more virtual machines doing a lot more work on here, well, they may stack up in this queue while they get scheduled to run and actually executed. Well, in a highly consolidated environment, this list of things in this queue can get really, really long. The more activity you have with CPUs, and it's a finite amount of physical resources, you may actually have some of these tasks stack up, and the longer they're in this queue, the longer it takes to execute. Now, it sounds weird, but the longer they're in that queue, it's one of the biggest silent performance killers that you will get in a virtualized environment. And if you don't get anything else from this whole presentation, please, please, please pay attention to this one. And I will stop and repeat anything here until everybody is 100% comfortable with this topic. This is the #1 performance killer that you will find in an average virtualization environment. VMware has a way to measure how long it stays in that queue. It's called CPU ready time. It's, the thing here, it's the delay between when you put that task in the ready to run queue and when it actually gets executed. There is a performance impact of high CPU ready time on SQL Server performance over at my home blog with this link here. But what you've got is a number of milliseconds spent per virtual CPU, per virtual machine in that queue on a 20-second polling interval. So to translate that, if you have a CPU, a virtual CPU that has a CPU ready time of 1,000, you divide that into 20,000 milliseconds, and that gives you 5%. That is a 5% CPU performance loss in that 20-second interval on that virtual CPU. It doesn't sound like much, but when you have something that is so latency sensitive as SQL Server, any serious delay there you're going to notice. And the problem is you don't have anything in a Windows event log or a SQL Server DMV. Nothing in there is actually going to tell you that you've just lost some CPU time because of virtualization overcommitment. What you can do is you can actually see this inside VMware under performance of the virtual machine, under the advanced performance profile. Chart options, drop all the counters, add ready. It's right there, very, very plain as day. But nobody ever knows what it is until you get it explained. Now the beauty of it is, actually just last week, Jonathan Cahias released a blog post talking about the equivalent of this. They finally opened this up and exposed it within Hyper-V. So Hyper-V 2012 and above, that's the perfmon counter that you want to watch, and that's a translation for what that actually means. Okay. I know that's a really nerdy, geeky topic. Does anybody have any questions there?
It doesn't appear that.
Okay. So I've seen really, really crazy configured environments. I've even seen a CPU ready time of 2.3 million. So if you think about the performance impact of that, my cell phone could have run that SQL Server workload faster. This is the #1 thing. I want you to go and take a really good look at your virtualized environments the second you get back to the office tomorrow. Again, hit that write-up right here, and it will tell you where that counter's at. It will tell you how to calculate it, because if you go back historically, it does a weird roll-up thing, and I've got in here how to translate all that. So again, any questions with that, please let me know. I'll be happy to help you interpret what you see. Okay, it's time for a little bit more fun here. When it comes to a standardized SQL Server disk layout, anybody care to give me an example of what you normally do?
Yeah. Do or should do?
Do.
Any takers?
Well, I mean, everybody, yeah, so one VMDK for the operating system, one for SQL Server. Hey, Sean, do you do any separation there with data, logs, tempdb, things like that? Okay. Well, what you see on the screen here is what I generally start with in my build template. No control over the layout. That is really unfortunate. What I'm going to do is I'm going to give you some talking points to go back to your virtualization and storage admin and really talk through why you actually do want to start to split this up some more. From a virtualization standpoint, if they're using virtual disks, it's no more overhead on their part. It makes it more flexible for you. What I start with, I always start for one underlying virtual disk for the operating system. I separate out the SQL Server install home. If I'm doing heavy replication, it's not always, but if I'm doing availability groups, transaction log shipping, mirroring, whatever, MSDB tends to get hit pretty hard. So I will actually move that out to its own disk as well. I'll have one or more disks for user database data, one or more disks for user database logs. I'll do something for tempdb, and if I have really heavy tempdb usage, I may actually move the logs to a different virtual disk. I'd always, not always, if I'm doing SAN-to-SAN replication or virtual machine replication, I will break out my Windows swap file to a different virtual disk. And what I can do is I can set that virtual disk to replicate on a much slower period than everything else, and that way I don't kill a lot of expensive bandwidth to replicate stuff that just doesn't matter. Super easy, simple to do. And then I'll carve off one for backups, because what I like to do is to do local backups and then pull them because of some quirks with Windows. Now, the reason I do all this is because I can hot grow anything that I need in a virtualized environment. I also go through, and you have the flexibility to move these individual things around under the covers. So I can have a great big fancy and expensive SAN. I can have these different tiers of disks, and what I may need to do, I may put my operating system on the cheap disks, because if Windows, it doesn't matter if I'm using SSDs or if I'm using SATA. It's just going to turn on and run. user data 3 might be, like 5 years of archival orders for some transactional order processing system. I may only fetch data off of that, very infrequently, say year-end or month-end reporting, things like that. I can park some of these other things that get used more frequently on faster disks, and then stuff that gets pounded all the time, I can park that on SSD. The beauty of splitting it all up, one, I don't consume SSD unless I need it because it's really expensive compared to regular disks. The other thing is, let's say I want to move things up for end-of-month reporting so I can improve the performance on that temporarily. You can actually, transparently to the operating system, you can move one of these virtual disks to a faster tier of storage. It's called a storage vMotion, or it's a storage live migration. You can do this and life is good. You can move it over to the faster disks, run reporting, whatever you need, and then move it back. Or if I find that somebody's parked another database that I didn't know about and they're just pounding it now, you can actually fix a lot of this. It's pretty cool. Okay, Windows Server operating system, there's something I want you to go check out. So first of all, on your physical and virtual machines, doesn't matter what it is, by default, Windows Server 2008 and above want you to be green. Go figure. But unfortunately, they want you to be green in a way where they force you, by default, to be green. So if you go to the control panel under Power Properties, by default, it is set to balanced performance for your CPUs. Unfortunately, what that does is, if you're on a new enough server architecture, that can actually artificially slow your CPUs down by 25%. Yeah, physical or virtual. You can download a utility called CPU-Z, and you can go see what the actual rated gigahertz of the CPUs are versus what it's running at today. If you find that those CPUs are running well below what they're rated at, this is exactly what's happening. All you have to do, and it doesn't even take a reboot, you set that power profile from balanced to high performance, and immediately you will watch that gigahertz rating jump right to where it needs to be. That can be up to 25% performance improvement of CPUs. It's crazy. So how many of you are going to go run back to the office tomorrow morning and go check this?
Quite a few.
Awesome. So everybody email me if you actually do find that this is causing you performance problems, and if you don't mind, send me some screenshots. I'm really curious out there to see who all's got what and what it's running at. So there's that. By default, best practices for SQL Server say format your disks to a 64K NTFS block size. If you haven't done this and you've got SQL servers in use today, don't worry about it. If you've got new machines in your provision, 64 already from your error scanning, there's a article that tells you because I'll say a log or a data file what it will do. So simple things to go exclude, won't take very long. The other thing is understand what your environment has running on that same machine as the SQL Server. You may have a lot of background stuff causing a lot of CPU activity, whatever. Just here. How many people some sort of ongoing performance to Oops, Brett, you still there?
Yay! Now we can hear you.
Woo.
There we
Awesome. Cool. Yeah, I asked a quick question there. Is there anybody in there that does ongoing performance metric collection?
go. There's one hand raised and a lot of nodding heads yes.
Cool. Excellent. Well, what I like to do is I don't care what you use. Just start collecting performance stats. It makes a huge difference. And when it comes to right-sizing that virtual machine, it makes an even bigger difference because now you've just established your baselines that you have available to you for that environment. If there's anybody on the call here that is not doing that, please send me an email. I will send you a document that will walk you through how to set up perfmon on all of your Windows servers to do 5-minute collection. There's a number of metrics in there it'll collect. It cleans up after itself, and there's no performance penalty for having this run. Because don't you want more information than less? You know, or if a SQL server is running funny, you know, overnight, you'll have these performance stats the next morning that you can go take a good look at. So if you need that, let me know. I'll send you the doc free of charge. I don't care. You need to have this stuff. Okay. Instance level config. These can get into some really interesting discussions. There's a number of things that I do in here that are not necessarily part of the defaults that I get into some good pros and cons discussion with people. So one, I will go through and set min and max server memory. Make sure to leave enough headroom for the operating system and all the crazy junk that's running in the background. If you do this, you can enable lock pages in memory, and that way, as a last line of defense, you are guaranteed that that SQL server will lock all the memory that it needs. Now, sometimes if you don't set this right, it's even at the expense of the operating system and other things going on in the background. So again, please make sure you leave enough extra room there for the operating system and all the stuff going on in the background. There's pros and cons to this. I've gotten into a lot of really good discussions with a lot of MVPs and folks out there, and I like to do this by default. It may not work for you, but in a virtualized environment, eliminating the option or eliminating the chance of paging is my #1 concern. So another thing out there, instant file initialization. It's one of those things, physical or virtual, just enable it. You know, again, if you have any questions with it, send me an email. What it does is if a SQL Server data file goes to grow or get restored, the engine is coded to write zeros through what it extends before it actually performs that operation. That way it guarantees that that block is there. Now, the problem is, let's say I want to restore a 1 terabyte database. It's got to write 1 terabyte of zeros before it actually performs the restore. Instant file init just says skip the read, the zeros. So I've got a couple of questions here. Do I use lock pages even with the balloon driver? The answer is most certainly yes. What I like to do, I do not disable the balloon driver. I always use lock pages unless there's a compelling reason not to. Because if the balloon driver kicks in, if the VMware admin, if the VMware admin had not put the reservation on the physical or on the virtual machine to make sure I'm not ballooning, that lock pages in memory is the last line of defense there. The balloon driver may kick in and may squeeze Windows to start paging, but my SQL Server buffer pool is going to be safe. And then is instant file init in standard edition? That is a really good question. I think it is, but I want to double check on that. Does anybody there know the answer to that one?
Anyone? No, a lot of shaking heads, no. Hey, Jared, if you're still on the line, do you know offhand?
No, I'd have to look at it too.
Okay. I've made a note there. I think it is. I really do think it is, but again, I'm going to double check on that. If you can send me an email so I have your contact info, I'll definitely get the answer back to you and Brett, so that way you can distribute it amongst the group.
All right, thank you.
Cool. Okay, so instant file init there works really, really well. You know, anytime you have a growth operation or a restore, it will save you a lot of time. It just works. Now, max DOP. The best practice by default is to set max DOP to the maximum core count in the NUMA node on the machine that you're on. In a virtualized environment, what I like to do is experiment with the workload, and sometimes it's suitable, sometimes it's not. But I will go through and set my max DOP setting to the virtual NUMA node core count. So if I have specified, let's say, 2 virtual sockets and 3 virtual cores each, I'll set max DOP to 3. Now again, experiment with your workload because it may or may not hurt or help you, but it's very workload dependent. So go check that one out. Now another thing here, cost threshold for parallelism is basically the setting that SQL Server uses in order to, okay, appearance, addition does not matter. Awesome. Cool. Okay, cost threshold for parallelism is basically some arbitrary number that the query engine determines if it can parallelize a query or not and be efficient with it. It was originally written a while back, and the cost threshold for parallelism by default is set to 5. And again, it's an arbitrary number. What I've found is that the greater the parallelization of a workload in SQL Server, when it's virtualized, if there's a lot of activity on that physical machine, the CPU, the wait, the ready times that I talked about, may actually contribute to slowing down, whereas if you can increase the cost threshold for parallelism, it may force it to single thread it, and you might actually get a performance improvement. So experiment with your workloads and see what works better for you, but it may actually pay off to bump that up. A lot of times I've seen a value of 40 or 50 actually really help. Now, when it comes to this thing here called large pages, who here has what you would classify an extreme SQL Server in terms of transactional volume?
Yeah, just you? Nope, nobody else.
Okay.
One.
So in a quick bit, can you get them to describe their workload?
What's your workload like?
We have transaction logs of about 1.5 per half hour.
A gig and a half growth per half hour for transaction logs.
Some of that's.
Ooh, that's awesome.
But
some of that was.
I think the application probably doesn't really do this.
Because it's a poorly designed application. As they always are.
Cool. Well, how much memory do you have in that machine? Is it quite a bit?
Yeah, don't know offhand. Thinking 16, but I'm not positive.
Thinking 16 gig, but not positive.
Okay. What you may want to do is try to put some more memory in there. It might actually help you if it's got more in memory. Now, one of the things that I look at, if I've got a SQL Server that's got 96, 128 gigs of RAM, what can happen here is that Windows has to maintain pointers to hundreds of thousands of 8K blocks. There is a way where you can force Windows to be more efficient with its memory management by changing the block size from 8K to 2 meg. It's called enabling large pages. It actually, you can get about a 15% performance improvement if and only if it's a tremendous amount of memory that you're using, and I would say greater than 128 gigs, and it's actively being thrashed. That said, I've only had to enable it 3 times in 10 years of doing this. So if you've got a crazy environment, it might be worth experimenting, but there's a lot of cons when it comes to enabling it. So if anybody out there really qualifies for this, I'll be happy. It was a 15%. Cool. If anybody out there really wants to know more about that, let me know, and I'll be happy to talk more about it. It's one of those things that I've had to use in an environment that was doing about 80,000 transactions a minute and was consuming about half a terabyte of RAM with a PLE of less than 500. It was pretty crazy. The other thing here, and this is almost a religious discussion for some people, tempdb data file count. And I know I'll hear a lot of groans in the audience.
A lot of chuck.
What I like to do, yeah, what I like to do here is to follow SQL skills recommendations. You know, I've been through all the IE classes, and I trust their opinions more than I trust most people's fact. When it comes to tempdb, what I like to do is one log file and then one data file per CPU core, up to 8 cores. If I have more than 8 cores, I'll leave it at 8 unless I discover pretty heavy tempdb file contention, and then I'll go 8 to 12 to 16, but I won't go beyond 16. Paul Randall proved that the algorithm that it uses to balance a large number of tempdb data files loses its efficiency after 16 data files. So I tend to stop there. And again, almost every time I set these up for big environments, I've never had to go beyond 8. But again, it's very workload specific, so your mileage there may vary. Now, another instance level setting that'll save you a little bit of base memory, trace flag 1118, I do. Trace flag 1118 forces the tempdb data files to grow at the same rate. So yeah, I do like to use that. I do that by default. And I don't know if you've seen it or not, but instead of managing the SQL Server executable trace flag paths, you can actually set a system-level stored procedure to execute on startup, and you can go set that. Now, do I put the tempdb data files on separate LUNs? That's a really good question. Here's my response there. It depends. And again, I love to hate that answer. What will happen is, if I have a workload that is so demanding that I am bottlenecked not by the storage but on a path to the storage, then I will start to spread out these data files, and be it user database data files or tempdb data files, whatever applies there, even logs. The more you spread them out, the more active paths you can have coming from the virtualization environment, and you might be able to take advantage of active controllers in your SAN to get greater aggregate performance out of it. And again, that's only in the most demanding environments, but it does make a small difference, especially if you're contended on those paths. So did that answer your question, Glenn? Awesome. These are great questions, everybody. I really appreciate it. Okay, who here does actual benchmarking of your environment?
2 hands raised. Wow.
So that's 3. So for everybody that raised your hand, if you can make it to SQL Saturday in Washington, D.C., I will buy you some kind of beverage of your choice, because very few people actually either take the time or even have the time to do performance profiling of their environment. Now, here's the problem. Hardly anybody has the time to do it because we're all just so running ragged with this stuff. But what happens when somebody comes to you and says the system is running slow? You are the DBA, you're the default blame acceptor until you prove that it's somewhere else in the environment. Guaranteed. Everybody should be raising their hands. Problem is, performance is truly subjective until you can take these different metrics and make them objective. It's one of the hardest things to do, but in my mind, it's one of the most critical things to do, because you have to be able to do this in order to repeatedly demonstrate performance. Performance is the single biggest indicator of system health.
Hey, David.
So I mean, I could go on. Yeah.
Hey, just so you're aware, it's 8:25, and we've typically got about another 5 minutes for our meeting on there.
Cool.
I just wanted to know if you felt you had enough time to get through.
Yeah.
Okay. All right. I won't interrupt you again.
Oh, you're good.
Okay.
So SQL Spade is awesome. I actually know the guy that wrote that. He is really cool. It's a great product. For those of you that do not do benchmarks, Please do. Go to SQL Skills blogs. Aaron Stellato has a string of blog posts about baselining over the last few months that are really, really good. The thing that I love to use for benchmarking is DVD Store. It's free. There is a link here to my blog that tells you exactly where to get it, what it is, how to configure it, and how to run it. I even put a bit in there about how to fix the big bug that comes up with it. Basically, it stress tests a SQL Server instance by creating a synthetic workload, loading it into a database, and executing a test against it, just like it was an online OLTP system for web-based DVD sales. What you get, and here's the command that I use to run it, and all it does is output number of orders placed in that time period. So I'll do a 60-minute test, go. Cool thing is you can run it, you can make a change to the system, you can run it again, see if there's a difference. You can run it on dissimilar systems and see instance level performance differences between dissimilar systems. It's really cool. And it keeps you from having to dig into code to find long-running queries, things like that. Now, I still like to do that, but this is the #1 thing that I like to start with. Fun part here is, if you look, what I did, and this was actually part of my Summit presentation, I took DVD Store and I tuned a virtual machine. Everything that I talked about here, I split up my data files and logs and everything, all the instance level configuration things, all of that. I turned it on and I ran it, and then what you've got is the output file here. And at the end of the day, this thing placed 386,000 orders in a 60-minute window. I turned it again and did the same thing with untuned, 269,000. At the end of the day, what you had is a whole bunch of similarities. The exact same hardware, exact same SQL Server, different configuration. One was a click-through default with just one virtual disk, plain Jane, no tuning. The other one was tuned. The non-tuned one ran 31% slower. Same hardware. So from a business perspective, let's say you have 50 SQL servers in your environment. You may have just saved 30 or 40 physical CPU cores worth of enterprise licensing through consolidation with no performance penalty. That's a big deal. If you have existing SQL servers that have been virtualized, every single thing that I talked through here, you can go retroactively do to those virtual machines, and you can, through DVD Store, through other metrics, you can objectively demonstrate the performance improvement. That's a big deal. So, yeah, bottom line, virtualize everything. It just works. So does anybody have any additional questions?
It doesn't appear to be any here. Let me see if there's anyone online. No? Anyone? Oh, one question. Oh.
Okay.
On the network multipathing, where you said you looked at the environment and you could see there was a problem, did you see that on vSphere? What did you look to find that problem?
Did you hear that?
I did not. Can you repeat that, please?
Okay, so the question was on the network multipathing example that you had. Where did you
discover it? What tool?
What tool did you use to discover the networking problem?
What I did is I set up 2 virtual machines, and it was actually 2 VMs in their environment. I used iPerf, a copy of iPerf on each, and I set up one as a server, one as a client, and I told server A to communicate with server B and do a stress test. And again, all these slides will be sent out, so you'll have a full copy of it. You'll know where to get it. And actually, if you hit my home blog, just davidklee.net, from about 2 or 3 weeks ago, you will see a full write-up for exactly how to use this. And what we did, we discovered that one path was It was a gigabit network, so one path, one way, ran at it's like 94, 95 megs per second. When we turned it around, it was running at 8 megs a second. That's not right. So what we did at that point, we communicated with some of the hardware guys, and they got us into a management interface on the switch. And we discovered, we ran the exact same test while we were profiling it, and we found a number of problems where a tremendous amount of TCP retries and errors and things like that. And then from that point, they took it from there, and they discovered their actual problems within the switch that they were discovering in some of the error logs. At that point, they went and physically looked at the environment, and they found a lot of misconfigurations with the cabling. And as a result of all the health stuff, they ended up replacing the switch, and they set it up in a test lab, and about 2 weeks later, it died.
Hey, Brian, just to answer your question, I am recording this presentation. Hopefully, it recorded it out online somewhere other than my laptop. But if it is on my laptop, I will get it hosted and send a link to everybody. Unfortunately, it won't have the best audio quality.
Well, if it's going direct through GoToMeeting, it should be okay. But yeah, we'll make it work.
Yep.
Awesome. Are there any other questions?
Anyone else? No.
Excellent. Well, hey, thanks everybody for attending. And again, if any of you have any other questions at any other point in time, feel free to reach out to me. It may take me a couple of days to get back to you because I'm a little busy right now, but I will most certainly get back to you.
Excellent. Well, thank you very much, David, for attending remotely. And thank you all for bearing with our audio difficulties. And there. I'm going to click stop on recording.